Okay, expansion of liquid in a container. The 70-liter steel gas tank of a car is filled to the top with gasoline at 20 degrees Celsius. Okay, the car sits in the sun and the tank reaches a temperature of 40 degrees Celsius. How much gasoline do you expect to overflow from the tank? Okay, why? At first, why the gasoline will overflow? Okay, it is because gasoline expands faster than the tank. Yeah, we know that both the tank and the gasoline inside the tank both sits under the sun. So both the tank and the gasoline get heated up. So both tank and gasoline both expand, but gasoline expand faster than the tank. That's why there is a gasoline overflow from the tank. Yeah, the tank just not expand fast enough. Okay, maybe I can draw a picture for you. See. Okay, I've drawn the picture for you. So both the tank and the this is the okay, this is the tank and this is the gasoline. Yeah, so both the tank and gasoline under the sun, both heated up under the sun, so both will expand. But we know that gasoline expands faster than the tank, than the steel tank. So this is initially the initial temperature is 20 degrees Celsius. So both get heated up to final temperature 40 degrees Celsius. Okay, and then initially we can know, because he say full is you can see over here they are filled to the top. The tank is filled to the top with gasoline. Okay, the tank is filled to the top with gasoline. So since he said filled to the top, that means the initial volume of the gasoline is equal to the initial volume of the tank, which is 70 liter. So they have same initial volume because they say filled to the top. Okay. However, when both expand and gasoline expand faster than the steel tank, so they are heated up to 40 degrees Celsius under the sun. So we know that the final volume of the gasoline will be more than the final volume of the tank because the tank just don't expand fast enough. So what happened is the gasoline will overflow. Some of the gasoline will overflow. So how to find the volume overflow? Yeah, which is this one. How to find this volume overflow, volume of the gasoline overflow? So we just use this one, the final volume of the gasoline. We know that the final volume of gasoline is bigger than the final volume of the tank. So that's why, because gasoline expands faster than the tank. Okay, so the extra, or the extra amount of expansion by the gasoline, rather than the tank, is the amount overflow. Because we know that the final volume of gasoline is bigger than the final volume of the tank, and the tank cannot not enough space to hold all the gasoline. Yeah, that's why some of the gasoline will overflow. Okay, so to find the amount overflow, which is the question asked, how much gasoline do you expect to overflow, is we just take the final volume of the gasoline, the final volume of gasoline minus the final volume of the tank. Okay, so this is the equation that we need. Okay, this is the equation that we need. This is the most important one. Okay, so what do we do now? And about volume, okay, for volume, we're going to use gamma. We are going to use gamma. Okay, so we are talking about volume, we must use gamma. But the thing is, he gives us, for the steel, he gives us alpha. For gasoline, he gives us gamma. So the gasoline, you can use the gamma, but the steel, you must change the alpha into gamma. Okay? Okay, I write down. Okay, we have the gamma for gasoline. Okay, we already have the gamma for gasoline, which is fine, 3, 9, this one, -6 per degree Celsius. Okay, but for the steel, it only give you the alpha, which is the linear expansion, coefficient of linear expansion. So you cannot put alpha, you must put gamma. So you must get the gamma for steel first. Okay, do step by step. So okay, so you must change to gamma. Gamma for steel, it is 3 alpha. Gamma is 3 alpha. Okay, this gamma is this steel is for the tank, yeah, for the tank. Okay, now let us find it out. So 3 alpha, 3 times 12, so you get 36. Exponent -6 per degree Celsius. Yeah, so this is the value we're going to use. Okay, we're going to use this gamma for gasoline. Okay, and we're also going to use this gamma for steel, gamma for the tank. Okay, so if you compare the values, yeah, look at the value for gasoline and for steel, both have the same exponent -6. But if you look carefully, the steel tank, the gamma for steel tank is only 36, but the gasoline is 950. Wow! So that's why the gasoline can overflow, because the gamma for gasoline is bigger than the gamma for the steel tank. Okay. Maybe you can write something over here. The gamma for gasoline, which is liquid, is bigger than the gamma for the steel tank, which is a solid. That's why we can say liquid expand faster than the solid. Okay, liquid expand faster. That's why overflow. That's why the gasoline overflow. Understand? Oh my god, my writing, yeah, and overflows. Yeah, because the gamma of gasoline is bigger than the gamma for the steel tank. Yeah, the liquid expand faster than the solid. Yeah, this is 950. This is only 36. So liquid expand faster than solid. That's why the gasoline can overflow. Okay. That's a reason. Okay. So now okay, yeah. So okay, let's do this to find the amount overflow. How much overflow is to find the volume of gasoline overflow. We take the final volume of gasoline minus the final volume of the tank. So we already got the gamma for both. Remember, the alpha you must change to gamma. This one is alpha, this one is gamma. You must change the alpha to gamma because we are using volume. Okay, volume. Okay. So to find the formula for final volume is the general formula for final volume is initial volume 1 plus gamma. This one use gamma delta T. Gamma delta T, change of temperature. Okay. For this one, the unit you can this change of temperature you can either use degrees Celsius or Kelvin. Yeah. Because yeah, you know why. Yeah, I already explained many times. Yeah, so the temperature degree Celsius, you don't need to change to Kelvin. Yeah, no need to change to Kelvin, just maintain as degree Celsius. Similarly, for this volume also, it gives us in liter, isn't it? A liter. So this liter also you don't need to change to the SI unit. Liter and liter, because left and right hand side have the same unit, they can cancel out. So you can maintain as liter. No need to change to meter cube. Okay. So you can maintain as the same unit. Okay. So let's do it. Let's find out. Yeah. First of all, let's find the final volume of gasoline, and then we find the final volume of the tank. Then only we minus. So we do step by step. Yeah. So this is our final step. We find out the final volume for respective individual first. Okay, so let's find out the gasoline. First we find out the gasoline. Okay, final volume of gasoline is the initial volume of the gasoline, and then 1 plus gamma for gasoline, yeah, gamma for gasoline, gamma for gasoline, and then T minus T naught, final temperature minus initial. This is the final temperature minus initial temperature. Okay, so let's find out the final volume of gasoline. So what's the initial volume of gasoline? It is 70 liter, isn't it? Because it filled to the brim, yeah, filled completely. So initially it's 70 liter. Okay, you write down the unit liter there. So later on your answer also in liter. And then gamma gasoline. Gamma gasoline is 950 exponent negative 6. Okay. And then final temperature is final temperature. That's why you draw a picture. All the data over here, you just take the data from here, substitute into your value. Yeah, don't leave your data inside the questions. Yeah, very hard to find. Okay, you draw a picture out, then easy for you, yeah, to solve the questions. So final temperature minus initial temperature. This is final, this is initial. 40 minus 20. Okay, 40 minus 20. Okay, so let's do it. Let's calculate. Let's calculate. Okay, so I got my answer. 71.33 liter. Okay, that's the final volume of gasoline. Now let's find out the final volume of the tank. Final volume of the tank, the steel tank. Final volume of the tank lah, just final volume of the tank, which is the initial volume for the tank, and then 1 plus alpha, not alpha, gamma, yeah, gamma. Don't alpha. This is volume. Use gamma, yeah. Be careful. This is gamma. Okay, this is gamma tank, and then final temperature minus initial temperature. Okay, okay. This one is for gasoline. This one is for the steel tank. Okay, now let's find it out. Let's substitute the value first. So what is the initial volume for the tank? Initial volume for the tank is also 70 liter. 70 liter. And then 1 plus, what is the gamma for the tank? Gamma for the steel tank is 3 alpha, yeah, which is 36 exponent negative 6. And then final temperature, which is 40 minus 20. Okay, let's find out the final volume of the tank. Okay, so I got the answer is 70.05 liter. Yeah. So you see, the tank expands slower, only 70.05. But gasoline is a liquid, expand faster, 71.33. So how much overflow? Yeah, tank expand from 70 to 70.05. But gasoline expand from 70 to 71.33. So the difference in the final volume, should be the amount of gasoline overflow. Okay, so we just take the final volume of the gasoline, which is a much bigger volume because expand faster, liter, minus with the tank, which expands slower and only has a final volume of 70.05 liter. So the difference, 71.33 minus 70.05. So the difference is 1.28. 1.28 liter. This is the amount overflow. This is the amount overflow. So here overflow is 1.28 liter. Okay, and whereas the container only has 70.05 liter. Yeah, expand from 70 to 70.05 liter, but there is a gasoline overflow 1.28 liter. Is the answer correct? Yes, it's correct. 1.28 liter. That's correct. Okay, 1.28 liter. That's correct. So that's it. That's it. Okay. Okay. That's it for the questions. Okay, thank you.